Hey guys, welcome to lesson 4.6 where we are going to continue talking about proportional equations just in a more formal manner today. So we have some good little notes up here about proportional equations. For starters, a proportional equation is one that compares two or more ratios. Oop, small line there. Proportional equations can compare two pairs of corresponding parts, okay, this means that the parts match, of similar shapes, or can compare two parts of one shape to the corresponding parts of another. So basically that's saying that I can make a ratio out of C and D and compare it to A and B. All right, I can do this. Or I can do this where I say A over C equals B over D. That's going to compare this to this with one ratio, and then this to this with the other ratio. Okay, so there's two ways I can set up similarity proportional equations, and those will help us solve for missing pieces. So, in this problem, we have to set up some ratios to justify that the rectangles at the right are similar. So remember what we talked about yesterday, right? In order for two shapes to be similar, all the corresponding side ratios have to be the same. Now we know that in rectangles, opposite sides are equal, so this side is going to be 6, and this side is going to be 2. And then here, this side is going to be 7, and then this side will be 21. All right, so really, because all these sides, like there's two pairs of equal sides, we can just go ahead and set up ratios with the vertical side pair and the horizontal pair, and that will be enough because all the other sides are equal to those. So let's start with the vertical pair. So let's go ahead and compare these two, right? I always like to put the big one on top if that's an option I have, so that's what we're going to do. All right, 7 over 2 is going to be that ratio. And if we actually did that division, we would get 3.5. Okay, and then if we made the other ratio, okay, 21 over 6, if you go ahead and do 21 over 6 in your calculator, you end up getting an answer of 3.5 as well. Ooh, that's an ugly 3. All right, so because these two are equal, they are similar. All right. The next thing here, this is extremely important, and this is what I'm going to be talking about and repeating over and over so many times. All right, and that's all about consistency. If Lynn wrote these two ratios to set up his equation, one of them was 2 over 7, right? 2 over 7. And the other one was 21 over 6, so 21 over 6. Well, what's the issue here? He was not consistent. All right, and here's the reason he wasn't consistent. Okay, in the first ratio, 2 over 7, he put the smaller shape on top. However, in the second ratio of 21 over 6, he put the bigger on top. And I've told you guys that you cannot do that, okay? It is absolutely illegal. You have to make sure that if you choose to go the big on top route, then you got to do that for both. If you go the small on top route, then you got to do that for both, right? You have to stay consistent. All right. So next we have just some examples of finding missing sides using proportional equations. So let's go ahead and match the sides that we can make ratios with. So like 6 and x must go together, and 2 and 4 must go together because those are matching sides. So now we'll go ahead and make our equation. We can say that 4 over 2 is equal to x over 6. Now again, notice how I was consistent, right? If I made my first ratio with the big number being on top, I have to make my second ratio with the bigger side on top of the smaller side. Okay, now I'm ready to cross multiply. And I get that 2 times x is 2x. 4 times 2 equals 8. So I'll go ahead and divide both sides by 2 to finally solve for x. These will cancel, and we get a final answer of 4. Okay, so that tells me that this side must be 4. All right, let's do another example. These shapes are kind of rotated a little bit, and that's all right. We just got to look a little closely and make sure we match the right ones. Okay, this 4 would make sense to go with this 3 because that's like the same position. And then the x will go with the 6. All right, so let's go ahead and set up our ratios. We have 4 over 3 for the first one, and then the second one will be x over 6. Again, notice my consistency. And once again, we will cross multiply to get 3 times x, and then equals 4 times 6. 4 times 6 is 24. We can go ahead and do that. And now we want to solve for x. So since we're multiplying by 3 right now, we can divide both sides by 3, and we find that x equals 8. All right, one more example here. Let's go ahead and match our sides. This question mark, we can go ahead and call this question mark x. And that one matches with this side. And you can just tell that by looking at the pictures. And then 16 will match with 24. Notice how there's like an 18 down here at the bottom, but it's kind of useless to us because there's no matching side with the 18. So we're just going to ignore it. It's just there to distract us. All right, so we're ready to start to set up our ratios. We'll start with 24 over 16. And again, if you guys choose to go like 16 over 24 instead, that's totally fine. Again, just make sure you're consistent, right? If I decided to do 16 over 24, then your next one would be x over 21 instead of 21 over x. Okay? Now that I'm all set up, I can cross multiply. All right, so now I have 24 times x is equal to 21 times 16. Okay, I can go ahead and take care of that multiplication. 21 times 16 is going to be 336. And my last step, as usual, will be to divide by this 24 to get x by itself. So x is going to be equal to 14. Right, and that is how you make proportional equations to solve for a missing side. Down here, just one little question. I do want to address this just to make sure we're aware. With these two angles, right, we notice that we took this diagram 1, and to create diagram 2, all we did was extend these sides, right? We just took these and we made them longer. But the question is, what happened to the 60-degree angle, right? Like if I took this and I just extended it, what happens to that angle? Oops. And a good way for us to see what happens is to trace over that angle. Let's take a look for ourselves. Right? If this, that's kind of a bad tracing. Here's my angle. And let's see what happens when I place it on top of the new one. Right? Notice how that angle still fits perfectly on top of that second one. So what that's telling us is that no matter what we do in terms of extending the sides, like changing side lengths, the angle does not change. And this goes back to when I told you guys that when we're talking about similar figures, the side lengths change, but similar figures always have the same angles. They always maintain angle measures. All right, and that is all for today. Go ahead and give the practice problems a try and make sure you reach out to us if you need any help.